This presentation covers the installation of modules in modular construction. Module sizes are limited by transportation to about 4.3 meters in width and 16 meters in length. A typical module for a residential building is 3.6 meters wide and 10 meters long. A module weighs around about 300 to 350 kilograms per square meter, which equals 12 tons for a module of 35 square meters floor area. A module with a concrete floor can weigh 500 kilograms per square meter, or up to 20 tons for a module of this area. Modules are lifted using beams so that the forces from the lifting cables are close to vertical and don't lead to any damage of the modules. Modules are weather protected, and so lifting points are located outside this layer. Here we see the use of a specialized lifting frame to support a module at 8 points, and also the bracing to the open side of the module to prevent damage during lifting. This is a good example of a specialized lifting frame with an integral cage, so that the operative is connected to a lanyard and then can unclip the module before being lifted away to install the next module. It's important that a lifting plan for the modular installation is agreed at the very early stage of the project, and this should include module weights and location, as they influence the crane size, the positioning of the crane and its boom length. It's also necessary to identify the approved person who's responsible for preparing and administering the lifting plan. And this should take account of local access, permitted times of working and weather conditions, etc. A typical installation rate is 6 to 8 modules per day on average, taking account of these factors. It's necessary to control accuracy of installation at each level and to define how this is achieved. The module-to-module connections should also be defined, including any other connections such as the concrete cores and cladding. Tolerances are very important in modular construction, and so the ground level must be very accurate. Up to about 3 mm maximum variation in level is considered. And the module position must always be controlled relative to a ground datum. The permitted maximum deviation of each module relative to the one below is 5 mm typically. But the maximum deviation over 10 stories is limited to about 30 mm. So obviously this requires greater control over the installation of a number of modules. A concrete core is generally more inaccurate than the modular construction, so the connection details should allow for this. This is a good example of protected covering to modules. In this case, 2 modules are installed on one lorry. And the modules are generally connected at re-entrant corners between the modules. And we can see here 2 examples of those connections. On the right hand side here you'll see a re-entrant corner with a plate at the base, so that the bolted connection is formed vertically between modules. And here the second case with a re-entrant corner where the connection is formed horizontally between modules, and that same bolt hole can provide a lifting point. And on the right hand side you can see the re-entrant corner can also have pre-welded nuts, so that the bolts can be easily connected without having to pass through the module. And this is an image showing how the corridor cassette may be connected to the module by the use of a plate that is screw fixed to the underside of the horizontal corridors and is then screw fixed or bolted to the vertical elements of the module, as shown here on the left. Generally, services are placed below the corridor, and normally the cassette floor of the corridor is placed as a two-dimensional panel, and for reasons of installation it's generally attached to the module beneath, as you can see here by angles. So the combined depth of the floor and ceiling of two modules is around about 450 millimeters, and this gives space for about 300 millimeter zone of servicing below the cassette floor. This is a good example of the planned form of a student residence, and you'll see here the flats are arranged with double corridors so that each flat can be accessed separately, and therefore the boundary around a group of flats and the kitchen forms one acoustic and fire separating boundary. And you can see here there are 4 study bedrooms essentially associated with one kitchen. Partially open-sided modules can be very efficient because they allow much larger spaces to be created, and you can see here how this is achieved with the use of an internal post, so that 3 modules together can produce one very large apartment. And generally speaking, half of the module side has to be provided with a wall in order that the vertical loads can be transferred through the module. Modules are often placed on a podium structure, which can be in the form of steel frame or a concrete podium, and this is accompanied by the use of steel stairs, as we see here in this image. High-rise modules have to be clustered around a core, which is shown here in yellow, in order that they are stabilized against lateral loads. And you can see here that each pairing of modules forms one apartment. And balconies are often attached to corner posts, as shown here. So here, this would be a square hollow section built into the corner of the module, and that allows the balconies to be suspended from it. So what have we learned regarding the installation of modular units? Firstly, that module weights and location should be carefully identified, as they will influence the crane size, positioning and lifting sequence. An approved person is identified under the LOLER regulations who has responsibility for the lifting plan. It's necessary to agree the plan taking account of local access, permitted times of working and weather conditions. It's also necessary to agree the control of accuracy of installation at each level and any remedial measures that are required. And also to agree how the modules to be installed and connected, including connections to concrete cores and cladding.